The location of several prominent geological features on Mars can be seen in this prominent panorama. At the top left and running about a third of the way to the center of the image is a portion of the delta front, a river delta that billions of years ago fed the lake at Zero crater. Below and to the right of that is a ridge called Fellefeu. Farther to the right at the top of the image is the distant peak called Santa Cruz, which is geologically interesting since it has mineral signatures seen both from orbit and by the Mars rovers consistent with alteration minerals, primarily clays. Near the top at the far right is a portion of the route Perseverance rover took to get to this location from where it captured this panorama. This crater sits in Utopia Planitia, the largest known impact basin in the solar system, with a diameter of roughly 2,050 miles or twice the size of Earth's Sahara Desert from north to south. The region is known to scientists for showing intriguing ice-related features on and below the surface, including frost on the surface during the Martian winter. This remnant of an ancient impact is just one of the many scars asteroids have inflicted upon the red planet. Water, volcanoes, and impacts from asteroids shaped the Martian surface in the ancient past, as Mars currently is a cold, dry desert planet. The crater is about 4.9 miles, with material ejected in a way that scientists believe suggests the presence of water ice. When the asteroid hit this region of Mars, the water ice melted and a mix of liquid water and dust rock was propelled from the top layers. The smooth look of the crater is consistent with other features in the region, having evidence of water ice history. Zooming into the crater, it is possible to see streaks on the walls of the crater, showing evidence of landslides and ripples sculpted by the wind. Contrasting textures and colors of a hill at the northern edge of Marathon Valley and swirling reddish zones on the valley floor just to the left are seen in this panorama. Marathon Valley is a high-priority destination for the Mars rover mission because observations from orbit have detected clay minerals here. Dark rocks on the hill here show a pattern dipping downward toward the interior of Endeavour crater to the right from this viewing angle. The strong dip may have resulted from the violence of the impact event that excavated the crater eons ago. The brighter rocks that make up the valley floor and the reddish zones here may be areas where water has altered composition. Inspections by Mars rover have found that compositions here are higher in silica and lower in iron than the typical composition of rocks on Endeavour crater's rim. This pyramidal rock was encountered by the Curiosity rover and measures about 9.8 inch high and 16 inch wide. Analytical studies performed on the rock by the rover suggest that the rock is an igneous rock but found to be high in elements consistent with feldspar such as sodium, aluminum, and potassium, and lower concentrations of magnesium, iron, and nickel than other such rocks previously found on Mars. The mineral content and elemental abundance indicates the rock is a maggiorite, a sodium-rich oligoclase-bearing basaltic trachyandesite very similar to terrestrial maggiorite rocks. Igneous rocks similar to the rock are well known but occur rarely on Earth. On Earth, such rocks form when magma, usually found in volcanoes, rises to the surface, cools and partially solidifies with certain chemical elements, while the warmer liquid magma portion becomes enriched with the left behind elements. The rock is a ventifact with a volcanic fabric. Its pyramidal shape was formed by aeolian drifted grains of sand. The little cavities on its surface were formed by the blast effect, which is caused by different flow dynamics at the micro-relief. On the surface, one could see the marks of the main wind direction by which the rock was formed. The rippled surface of a high Martian sand dune fills this view. This site is part of the Bagnold Dunes field along the northwestern flank of Mount Sharp. The Bagnold Dunes is a 22-mile group of dark gray dunes in the Gale crater on Mars. The dunes here are active and migrate up to about 1 yard or a meter every Earth year. Curiosity Mars rover captured this panorama where both the floor of Gale crater and upper Mount Sharp are seen through a dusty atmospheric haze. Scientists interpret the curving and overlapping layers in the bedrock around the rover as evidence of cross-bedding, which occurs when layers are deposited from wind-blown sediment. The atmospheric pressure on Earth at sea level is about 1 bar. On Mars, the pressure is 6 to 10 millibars or 1 per 100th that of our planet. But even in this atmosphere, wind still flows around obstacles. In this image from NASA's Mars Reconnaissance Orbiter, the ripples in the sand tell us which way the wind was moving and how it was diverted around these rock formations. Typically, the wind direction is perpendicular to the crest of the dune, or in this case, the ripples.